What up, what up? Let's finish Unit 1 of AP Precalculus, shall we? We're hitting the last 4 sections, lots of modeling, kind of like what I did in college to pay the bills. And let's just jump right into it. The first thing that we're going to see is the binomial theorem. Now, what's the binomial theorem? Well, let's just say you have a binomial, like x plus 7. And you want to take that parentheses and write it out to the 8th power. And you're like, whoa, that's a lot of foiling. More foiling than if I worked at a fancy restaurant. I agree. So thankfully, we have the binomial theorem to help us get by. Now, the binomial theorem uses what's called Pascal's triangle. All right, you start out with 1 up here, and then you put a 1 here and a 1 here. And then from here on out, whatever number's on the outside is just always going to be 1, but whatever number is in the middle is going to be the sum of these guys. So you would be 2, and you would be 1, and you would be 1, and 1 plus 2 is 3, and 2 plus 1 is 3, and 1 is on the outside, and you put 1 on the outside, and 1 plus 3 is 4, and 3 plus 3 is 6, and 3 plus 1 is 4. I struggled with that one there, and 1, and then you could keep going and keep going. Now, why does this matter? Well, the binomial theorem follows this interesting pattern where if you have a polynomial, or if you have something in the form x plus y, actually, you know what? I prefer to do a plus b. Let's do a plus b. I like those letters. Let's do that. If you have something in the form a plus b to the a power, no, we can't use a. Let's use the d power, d for degrees, to the d power. If the d is 0, you're going to use this guy, and we would never use that guy. If the d was 1, if the degree was 1, we would use u. In other words, a plus 1. We would use this for degree 2. We would use this for degree 3. We would use this for degree 4. Now, what this looks like is if I were to give you an example like x plus 9 cubed, okay? That's going to follow that row right there, okay? Now, the binomial theorem states that for a plus b to the third, what you're going to write out is you're going to write out a to the third. So actually, invisible 1, a to the third, plus 3, a squared b, see what we're doing, plus 3, a b squared, plus 1 b cubed. All right, what we do is we start out with that value, we have it peaked out at the degree, and we move it down until we get to nothing at the very end. And on the way to the right side, we peak that out at 3, and we move our way to the left until we get to the very end, and these numbers are our coefficients. So if this was something like a plus b to the fourth, it would follow the same rules. Let's get some different colors. You would have 1a to the fourth plus 4 a to the third b plus 6 a squared b squared plus 4 a b cubed plus 1 b cubed. Now that takes us back to this guy right here. Okay, knowing that we're going to use this, what is that going to look like? Well, I will label u a and I will label u b. So I shouldn't have used 9. It's too late. I've already committed. I'm going to write out 1 x to the third plus 3 times x squared times b. Okay, see what I did? Plus 3 times x times 9 squared plus 1 times 9 cubed. And then it's just a matter of simplifying. I don't need 1 in front of x cubed. Okay? 3 times 9 is 27, 27x squared. Plus 3 times 81 is going to be 243x. 9 times 9 times 9.
It's 729.
I knew that. Okay. So that right there, boys and girls, is the binomial theorem in action. Next thing that we're going to look at is transformations. Now, if I were to take this picture right here, okay, and move it down and over, of course, with the arrow there, that's called a transformation. Okay, there's 4 main types of transformations that we're going to deal with. Transformation type number 1 is going to be a vertical translation. Okay, a vertical translation. Translation is movement and movement only. If I give you f of x, right? So f of x equals some quadratic like that. And then all of a sudden I give you a new one and say, all I want you to do is add 3 to it. That is a vertical transformation. The positive 3 means you move up. If it was a negative 3, you'd move down. Similar, if I have a horizontal translation, this is similar but gross. If I give you f of x, if you throw a negative inside the parentheses with the x, next to x, okay, like this, and this is what's going to annoy you, if it's negative, you move right. So negative means moving right. Positive means moving left. It's opposite land whenever you're working within the parentheses. That's just the way it is. That's just the way it is. According to Tupac, things will never be the same. Okay, Changes. Great song. Great song. Rest in peace, Tupac. Too young. I mean, a lot of people think he's still alive, but who knows? All right, now we're going to talk about a dilation. A dilation is when your shape stretches, widens, whatever. Okay, and there's a couple types of dilations. Now, the first one is called the vertical dilation. Okay, a vertical dilation is basically you're taking your shape and you're squeezing it depending on what's going on. The way you do that is you take some number and you just multiply it to your whole f of x. And what that looks like in this case is this gets skinnier. Okay, this gets skinnier. It's also called a stretch because when it gets skinnier, what it looks like if it's a vertical dilation is if you were to take your parabola and like grab it from the top and pull it. And so what happens is by pulling it, it goes like this. And so that's the vertical dilation. If this number is in between 0 and 1, it is also a vertical dilation, but it's called a compression. And what that looks like is if I give you a parabola and squeeze it downward, that's a compression. It makes your thing look wider. So a vertical dilation is when you have a number multiplied to the whole function. Now, if I were to give you a horizontal dilation, the way you handle that is very similar to the horizontal translation, and you only multiply the x by a number. Okay, so f of x, and this is, oh man, this is going to be fun. You ready? F of 1 over like a number, x. Okay. And by putting it 1 over a number, by 1 over a number, you are saying if it's 3, 1 over 3, you are doing a horizontal stretch of 3. Whereas if it was regular 3, it would be a horizontal compression. Okay? So the wording is weird. It's not pleasant. Again, I highly suggest you watch videos on this stuff because, the wording is not pleasant, but, it is what it is. Now, we know linear, quadratic, and cubic models. We've done this before, but let's just bring it all back. A very common question is I give you a chart, whether it's a T-chart that looks like this. I'm just going to use these numbers that I quick whipped up, so sorry for looking off to the side. Very unprofessional of me. -6, -5, -4, 3, 22, the Taylor Swift special, and 59. Okay? Now, a very common question is, find a model that best fits the data. All right? So we're thinking, all right, well, is it linear, is it quadratic, or is it cubic? Let's do the rules. If it's linear, all right, all of these go up by the same number, consecutive equal length input value intervals. I got it. I said that phrase and I said it correctly for once. Okay, what am I doing over here? Well, to go from -6 to -5, I add 1. To go from -5 to -4, I add 1. To go from -4 to 3, I add 7. To go from 3 to 22, the Taylor Swift special, I add 19. And to go from 22 to 59, I add 37. Definitely not linear. Okay, definitely not linear. And in this case, it's not concave up. See, I look at this as like rate of change. My numbers aren't increasing right away. So this tells us that it's probably not going to be quadratic either. But we don't know that. We don't know that. I'm gonna pretend that I didn't say that. Let's test for quadraticity. And the 100% is not a word. Add nothing. Add 6. Add 12. Add 18. Are these numbers the same? Are the rates of change of the rate of change the same? No. So it's not a quadratic either. So let's see if the rate of change of the rate of change of the rate of change is the same. And oh, happy day. You add 6 in every time. Uh-oh. Not even Catholic. It's cubic. So a problem like this, you'll often see determine a model that best fits the description. Now that I know it's cubic, I can answer questions like this. Now, with questions like this, let me move my face. We are going to use the calculator. In a previous video, when I do the thing where I put the calculator on the screen, it somehow like cancels out my voice sometimes. So I'm not going to do the thing where I go like this and look at the camera. I know you, all 12 of you who watch these, find that so funny, but that's not what I'm going to do. I'm just going to split screen right now and show you how to do the linear regression, quadratic regression, and cubic regression of each of these. Let's start out with linear. All right, let's talk about linear regression, quadratic regression, and cubic regression. All processes are done pretty much the same way. Whenever you're asked to input data, you're going to go over to stat, hit stat, and go right to edit. It gives you all of these lists. Right now we're focusing on two lists, L1 and L2, and we just start typing things in. I can probably get away with using my keyboard, so I'm going to do that and hopefully not make a mistake. All right, so you just make sure you type in your number, hit enter every time, move to the right, and do it again. So we have 3, 11, a terrible band, 19, 27, and 35. Right now we're going with the known fact that this is linear. I know this is linear. You know, in the previous slide we talked about how to tell if it's linear, quadratic, or cubic. In this case, I know it's linear, so I'm going to find the linear regression. So I'm going to always quit by doing second mode. That step might not be necessary, but at the very least, I'm out of where I need to be. To do linear regression, hit stat, go over to calc, and find linreg. Now, if you see the other linreg, this is more for statistics. This is more for algebra, calculus stuff. So we're going to go with 4. So you can either hit 4 or go down to 4 and hit enter. We need to calculate, so you can just hit enter a bunch of times and calculate. And it gives you y equals ax plus b, where a is 4 and b is 3. So the way we recognize this is you write this out, okay, slope-intercept form, where instead of a you have, or instead of m you have a, and you just substitute this in. So our final answer here that I'm going to write out in a second is y equals 4x plus 3, linear regression. All right, so the linear regression gives us y. The linear regression gives us y equals 4x plus 3. All right, let's take a look at quadratic. All right, let's do quadratic regression. Now, if I were to go and do the same thing, I'm going to purposely do this, hit stat, hit edit, and I still have the data from my previous problem. Now, the data that I'm going to use is completely different. So if you're using like a school calculator, or in my case, I'm using this calculator that I have online, you can clear your calculator by doing second plus 712, and that clears everything. Okay? So that's out of the way. So let's pretend that never happened. Let's do quadratic regression. I have to input values, so go to stat, go to edit. You have your L1 and your L2, just like we did with linreg, and we're going to type this in. Now, I can't get away with typing it using my keyboard, because if I were to use the negative button, it thinks it's the minus sign. And the only place ever that I've noticed in all of my life where there's a difference between a minus sign and a negative button are these TI calculators. Get your act together, Texas Instruments. So I have to actually, compute this in. -3, enter. -2, enter. -1, enter. And now I can just type the rest in. 0, enter. 1, enter. 2, enter. 3, enter. Then you go to L2 and you type those values in. 2, 0, 0, 2, 6, 12, 20. Now, we already know that this is quadratic, so we don't have to worry about finding out which one it is. We're just learning how to use this, or reteaching how to use this. So I'm going to quit second mode, and the process is almost the exact same as linreg. Go to stat, go to calc. Instead of linreg, go to quadreg. So you can hit 5, or you can go down to 5 and hit enter. Go to calculate by hitting enter a bunch of times. Once you hit calculate, you get exactly what you need. So you have what's the standard form of a quadratic equation, y equals ax squared plus bx plus c. A is 1, so replace that. B is 3, so replace that. C is 2, so replace that. And at the end, we should have y equals x squared plus 3x plus 2. That's our quadratic formula. Quadratic regression gets us y equals x squared plus 3x plus 2. Same exact process as this one. Let's go to this guy right here, cubic. Cubic Red, or Cubic Reg, or Cubic Frog, which is a company that makes toddler games. I would know, I have a toddler. If I hit stat edit, just like I did last time, there's a mess there. So it wouldn't be the worst idea to hit second plus 712 to clear anything. Now, if you have your own personal calculator and you have stuff saved, you don't want to do this, but this is from the internet, so I don't care. Hit stat, hit edit like we did last time, and type your values in. Okay, 0, 1, 2, 3, 4. And I can get away with using a keyboard because I don't have to worry about negatives. 2, enter. 3, enter. 10, enter. 29, enter, and 66, enter. So the numbers change, and they change a lot. We know this is cubic. Don't have to worry about adding and finding rates of change of rates of change of rates of change. We're just going to quit out of this by hitting second mode. Go to stat. Very similar as the last two. Go to calc, but instead we want cubic reg, and it gives you a general form after I hit calculate. And there it is. So this is where it gets a little interesting, and we just have to be a little careful. Keep in mind that, TI is not flawless. You already heard my great meltdown of the minuses and the negatives, but that is what a cubic looks like. You got x to the third. So I would write out y equals 1x to the third, but actually not write out the 1. What is this? Well, this has negative 4.2 e to the negative 12. Well, e means times 10 to the. So if you've ever used these, if you ever use like scientific notation, this is scientific notation. And what this number is negative 0.00000000, like 11 of them for 2. And 0.00011 of them for 2 is going to be 0. So whenever you see e to the negative something like this, assume it's 0. So A is 1, B is nothing, C is nothing, D is 2. So basically we're eliminating both of these middle terms, and we're going to be left with y equals 1, or just y equals x cubed, skip, plus D, and D is 2. Y equals x cubed plus 2, cubic regression. Y equals x to the third plus 2. Those e's are weird, but if you see them now, you know what to do. All right. Right off the bat, find x or f of x, which is, binomial theorem. Now, we saw from earlier that binomial theorem requires Pascal's triangle. This is x to the fourth. So this is degree 0, degree 1, degree 2, degree 3, and degree 4. I'm going to label you A. I'm going to label you B, and let's just get right to it. 1a to the fourth is 1x to the fourth plus 4a to the third is x to the third. B to the regular is just 4 plus 6. A squared is x squared times 4 squared, a fun game, plus 4. Regular A is just x times 4 to the third is 4 to the third, plus 1 times 4 to the fourth. Okay? 1x to the fourth is regular x to the fourth. 4 times 4 is 16, so plus 16. X to the third. 16 times 6. I'm going to cheat. 16 times 6.
It's 96.
It's 96. X squared plus 4 times 4 times 4 times 4.
That would be 256.
And then the same thing. Yeah. All right. Explain how g of x is a transformation of x or f of x. So I have a 3 in front of my parentheses, not inside my parentheses, which implies that I'm taking f and multiplying f by 3. So be careful. Be careful. What I'm going to do is I'm going to say this. I'm going to pull a 3 out of this whole thing. That leaves me with 3x plus 4 to the fourth minus 4. So what I have is I'm multiplying 3 to f of x. Okay. So let me write that out. Explain how g of x is a transformation of f of x. Well, f of x is x plus 4 to the fourth. G of x Explain how g of x is a transformation of f of x. Okay, g of x is 3 times x plus 4 to the fourth minus 12. Well, f of x is x plus 4 to the fourth minus 12, which means g of x is 3 times f of x minus 12. So what I have is I have a vertical dilation of 3 because 3 lives in front of f of x. So let me say that a vertical dilation of 3 and they want to say, I think I use translation. They might use shift. So vertical translation or shift, whatever wording they use, translation of 12, which means we move 12. So vertical dilation of 3 implies that I stretch it, make it skinnier, and then move it down a bunch. All right. Find the remainder of f of x over h of x. Okay. Well, I found out what f of x was. I have h of x right there. Polynomial long division, baby. So h of x, I don't think I even gave myself enough space. Time to draw small. h of x is this. Ooh, I'm missing an x squared. Make sure you fill that in. X to the third plus 0x squared plus 4x minus 1. F of x ended up being that whole thing, x to the fourth plus 16x to the third plus 96x squared plus 256x plus 256. This is going to be awful. X, actually no, well, it's going to be two steps. X to the third times x is x to the fourth. Multiply that x to all four of those things, so you got x to the fourth plus 0x cubed plus 4x squared minus x. Flip the signs of everything. Minus, 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 plus. You go away. U becomes 16, because x to the third times 16 gives me 16x to the third. I jumped the gun. Sorry. Plus 92x squared. Shouldn't you have been? No, I did it right. So plus 257. X, drop down to 256. Ugh. All right. Plus 16. So let's multiply 16 to that. 16x to the third plus 0x squared plus 64 x minus 16. Cross you out. So 92x squared. Oh, flip the signs. Don't want to do that. Don't want to make that mistake. 92 plus or minus nothing is just 92x squared. I think it's 97. Let me just make sure. 157 minus 64.
It's 93.
See, that's why I check. And then this should be 272. So this guy, that one, that guy right there is my remainder. Okay? I could write that out as a factor, but that's going to show up later in this, so I'm not going to. All I had to do was find the remainder. I never said it was easy. I just said it would be fun. Now what this means is this times this gives me this. No, never mind. Let's just move on to the next one. I'm saying too much already, and I'm making myself look stupid. Pretty easy to do. A, what is the domain of f of x? F of x is Rx over Q. Oh, you're Q. So Q would be the denominator. Okay, so the domain is where Q of x is not allowed to be 0. So these guys are not allowed to be 0. Well, let's factor you out and see what you guys would be. You guys add up, the numbers that add up to 7 and multiply out to 10 are 5 and 2. So I wrote that out completely wrong because I've been doing this for a while now. X plus 5, X plus 2, which implies that x cannot be negative 5 and x cannot be negative 2. So if we write this out in interval form, we would say that the domain, you could say, is all real numbers except negative 5 and negative 2, but my domain is negative infinity, also can be written as negative infinity to negative 5, but not including negative 5, union, negative 5 to negative 2, union, and negative 2 on forever. Okay, so the domain is where, or it's everything except for where the function is undefined. The function is undefined when q equals 0. Q equals 0 at negative 5 and negative 2, so q can't be negative 5 and negative 2. List all the zeros, holes, vertical asymptotes, and slant asymptotes of f of x. Okay, so let me write down this whole thing. Okay, now that I have it all factored out. Okay, x plus 2, x minus 4, x plus 5 over, what was it? X plus 5, x plus 2. List all the zeros. The zeros exist when the numerator is equal to 0. So when the numerator is equal to 0, my zeros are going to be the opposite of u. So x is negative 2, the opposite of u, 4, and the opposite of u, negative 5. Now that will change in a minute because holes exist where my factors upstairs and factors downstairs are the same. So that happens at x plus 2 and x plus 5. So my holes exist at negative 2 and negative 5, which means if I were to graph these, right? If I were to graph these, basically this guy takes on the role of just a linear function. So I have to go up here and say, all right, well, if the holes are at negative 2, then a 0 can't be negative 2 because you're not allowed to plug in negative 2. Therefore, you can't get an answer. Same thing, my 0 can't be negative 5 because you're not allowed to plug in negative 5. So my only 0 here is 4. Okay, all right. Good thing I checked, huh? So what are the vertical asymptotes? Well, the vertical asymptotes are where you would have a breakage due to the fact that you have a very what's the phrase, where you're not allowed to use a, I don't know. There's a word and it shows up later here where you're allowed to have, or you can only have the number once in the entire problem. Well, the fact that x plus 5 and x plus 5 is repeated and the fact that x minus 2 is repeated, basically it insinuates that these guys are gone. So what's my vertical asymptote? I don't have any. Kind of weird. It starts with a D. It's going to bother me. Distinct. So since these guys are not distinct, they're indistinct and they're gone, I have no vertical asymptotes. Now, I'm still not allowed to plug in negative 5 and negative 2, but I have no vertical asymptotes. My slant asymptote is found by doing polynomial long division. Now, I have q of x. What I don't have is r of x completely simplified out. Okay, now here's the thing. Life is going to be a little good because you'll expect to see things disappear. We'll get there in a little bit. Actually, no, we'll get there now. When this is graphed, this thing takes on the role of a linear equation that looks like this, where you're not allowed to plug in negative 5. So negative 5 over here is a hole, and you're not allowed to plug in negative 2. It looks like that. So what is the slant asymptote? The slant asymptote is y equals x minus 4. Remember, the slant asymptote is a line that basically goes through whatever polynomial that you have that shows you where the asymptote would be. And since we're only left with an x minus 4, if I were to divide that by that, I would get x minus 4, which makes this guy super easy because this guy, I don't have to do polynomial long division. It's x minus 4. So that's it. I'm done. Oh, how nice. How nice. And I'm super glad looking at this I didn't make a mistake. Otherwise, I'd have to go back and change all of that and do a lot of really frustrating work, and I don't have to. This is where I think we start seeing calculator problems. Maybe it's the next one. This is from like section 11 or section 12 where we'll start to do some word problem-y modeling. This is a very calculus-like problem, okay? I taught calculus for years. I give this exact same problem every single time. An 18-inch by 12-inch regular piece of cardboard paper has X-inch square cuts in all corners to create a box with no lid. Let's draw that out. Okay, let's draw that out. I'm going to draw a rectangle. As you can see, everything is perfect. And according to this, I cut out X-shaped corners, squares, out of each corner. In calculus, this is called optimization. Now, we're not going to do as much as you would see in calculus, but you will see a problem like this in calculus. So this is gone. This will now get cut out. This will get cut out. This will get cut out. This will get cut out. Imagine you taking what's left over at here and what's left over at here, and imagine folding those up, and you now have yourself a box. Find the equation of the volume of the box. Well, when I fold these things up, when I fold you up along this line and fold you and fold you and fold you, I now have a box with no lid. Okay? Now, when I fold these up, how tall is the box going to be? Well, since I cut out X corners, the height is X. If this whole length was 18 and I just cut out two X's, that X right there, and I cut out X, now my length, if the whole length was 18, the length of this guy, just the part that's left over, is going to be 18 minus an X, so 18 minus 2X. So the length is 18 minus 2X. If you were 12, and I cut out an X and cut out an X, what's going to be left over is 12 minus 2X. 12 minus 2X. Volume is found by multiplying length times width times height. So an equation for volume is X times 18 minus 2X times 12 minus 2X. Okay? Now let's use common sense here for B. What are possible X values that can be used? I'm not going to be like, all right, well, let me try cutting out pieces of cardboard. Let me try out cutting like 10 inches and 10 inches. If you do that, you have no box. At some point, if this whole thing is 12, okay, if this whole thing is 12, you can't cut out 10, because if you cut out 10, you're subtracting away 2 times, you're subtracting out 20 inches. So how are you going to cut out 10? So the largest amount that you can cut, the largest X, is going to be, you go to the shortest side, which was 12. What is the largest thing that you can cut out that would make it disappear? Well, the number that would make this disappear is 6, because 12 minus 2 times 6 is 12. 12 minus 12 is 0. So the largest number that I can cut out is 5.99999, and I still have a little tiny sliver out of a box. So what I will say is I can cut out anything smaller than 6. And you know what? I can cut out anything bigger than 0. Like if I wanted to, I can cut out 0.1 or 0.01 or 0.001, but I can't cut anything that is 0 because there is no cut, but I can cut out 0.1 of here. I can cut out 1, I can cut out 2, I can cut out 3, I can cut out 5. But, 6 is the largest that I could do, but not equal to 6, and 0 is the smallest I can do, but not equal to 0. I could also write that in interval notation, where I need to make sure that I don't make these brackets. Now, the question here is, if I do this and I make a box where I cut out 4-inch squares or I cut out 3-inch squared, which one of these is going to be the bigger volume? Well, let's test these out using this guy up here, because this guy up here is friendly enough. For the 3-inch squares, my volume is going to be 3 times 18 minus 3 times 2, which is 6. 18 minus 6 is 12. 12 minus 2 times 3 is 6. That gives me 6. So 18 times 12 is 2. 18 times 12.
It's 216.
That's when X was 3. What about if x is 4? Okay, well, the volume is going to be x, 18 minus 8, 12 minus 8. 4 times 10 is 40 times 4 is 160. So which is larger when x is 3? Optimization problems. Will you see one this chaotic on an AP pre-calculus exam? No. No. I mean, this ended up being a cubic. We don't see cubics a ton, but we see them. It's just, don't be surprised if you see a problem like this in the future. You never know with AP. You never know. All right. Now I think it's calculator stuff. So if I move my face, yeah, there's calculators for all of them. All right. What sequence of transformations would turn f of x into g of x? Okay. So what it looks like I'm doing is the difference between f of x and g of x is I'm not multiplying f of g to anything, thank God. But what I'm doing is I went from x being plus 7 to x being plus 1, which means I have a minus 6 next to x. Now, when minus 6 is next to x, that means I move right, or a horizontal phase shift of 6. I also go from -3 over here. Remember, when the number's off to the side and has nothing to do with x, I'm going from -3 to 4, so that means I'm going up 7. So a vertical phase shift of 7. Okay? Not so bad. By the way, when I create these problems, I only wanted to use a calculator for this one. If this is a calculator section on an open-ended problem and you're allowed to use the calculator for this whole thing, graph that and see what happens. All right, find the domain of g of x. All right, the domain of g of x is what x values am I not allowed to use? Well, I have a fraction. I have a fraction, and in my fraction, the denominator is x plus 1. I'm not allowed to plug in -1 because that would make the whole thing undefined. So x cannot be -1. So I'll write that out as everything from -infinity to -1 union, and from -1 to positive infinity. Okay, or you can write it out as all real numbers except x equals -1, or x cannot equal -1, or whatever. Find all zeros for f of x. All right. F of x, when you are given a rational function, f of x, the way you find the zeros is you set the numerator equal to 0. Okay, well, my numerator doesn't have a lot of stuff going on. So what I can do two things. Let's do this. Let's make life a little easier. Let's say 0 equals 5 over x plus 7. Okay. Minus 3. If I add 3 to both sides, I now have this. Okay. Multiply both sides by x plus 7. That requires me to distribute. So 3x plus 21 equals 5. Subtract 21. 3x is going to equal -16. Divide by 3. 5 and a 0.3 repeating. -5.3 repeating, or something like that. The other way to do this was you combine fractions and then set the denominator, the numerator equal to 0. That would work. I think you'd end up with the same thing anyway. With this one, I'm going to split screen. Not split screen. I'm going to put in what I did on the calculator, show you what I did, come back out, we'll write out the answer. All right, for this guy, we already have a bunch of stuff going on, and what I'm being asked to do for part D is set f of x equal to g of x and solve. So this is what I'm going to do. I'm going to pretend that this is a system of equations, and I'm going to go to y equals and graph f of x in y1 and graph g of x in y2. Now, I'm going to graph this in the way that these were given to me. I'm not going to go up somewhere on the slide where I kind of simplified and combined fractions. I'm not going to do that, although I could. I won't. I'm going with the original because what if, God forbid, this is like an open-ended problem and I accidentally got one of those guys wrong? I would get this one wrong too. So I'm going with the original. So I'm typing out f of x and y sub 1. Okay, f of x was 5 over x plus 7 minus 3. So the way I do the 5 over x plus 7 is I'm going to create this big fraction. I'm going to do 5, and since 5 is the only 3 in the numerator, I could just go right to there, over parentheses x plus 7. Now, I've always been super paranoid with fractions on the TI-84 pluses. I don't know why, it's just my thing. I just wrap the whole thing in parentheses because why not? It doesn't hurt me. Okay, physically. Now there is my 5 over x plus 7 minus 3. If you were to rewind or fast forward, you can see that. Now I'm going to type out g of x, which is 5 over x plus 1 plus 4. So I'm going to parentheses. Since 5 is the only thing in the numerator, I don't need the parentheses that, divided by x plus 1. So x plus 1, close it, and then plus 4, now that my fraction is done. Okay, what this is going to allow me to do if I hit graph is it's going to give me both graphs the way they originally look, and both graphs, and if I'm using the color edition, I realize most schools don't have the color edition. In this case, I see both colors for the different ones. So f of x, I believe, was blue, and g of x, I believe, was red. Now I'm solving. When you solve a system of equations, which is what I did by typing out two different equations, I care where they intersect. They intersect here and they intersect here. So I only want the x values when I solve for x. So this is what I'm going to do. I'm going to find where they intersect here first, and I'm going to do that by hitting second trace and go down the intersect, or I'll just hit 5 in this case. Now, if I'm looking for that intersection point, I'm going to move my cursor to the left of the intersection point. As Cupid Shuffle would say, to the left, or in this case, maybe cubic shuffle. Anyway, my cursor is to the left of my intersection. I'm going to hit enter. Those of us who remember doing zeros in previous videos, this is very similar. Now the second curve, I'm going to move to the right, and it shows me the second curve, and it gives me, once I hit enter, it doesn't actually show me the interval, but right now I have a dot here and a dot here, and my intersection needs to be in between. So if I hit enter, it gives me the intersection of negative 6 point blah, 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 blah. This is precalculus. So I'm going to make sure I have 3 decimals, and 0.1712 rounds to 0.171. So my first 0 is negative 6.171. What about y? What about y? I'm being asked to solve for x. I'm not being asked to solve for y. So let's find the other one. Same process. Second, calc. I want to go to intersect. I care about where they intersect here, so let's move to the right a little bit. Hit enter. Now it shows up on the other curve. Let's move to the right a little bit until it crosses where they intersect. So that looks good to me. My 2 dots are blinking, and my intersection has to be in between both of those blinking dots, which it appears to be. If I hit enter, I get 1 point blah, blah, or I'm sorry, negative 1 point blah, 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 blah. Okay, and it appears to be negative 1.8285, so that'll round to negative 1.821. So those are my 2 zeros. Okay, those are my 2, I shouldn't say zeros, those are my 2 x values. Okay, negative 6.171 and negative 1.821. Okay. So we got x equals negative 6.171 and negative 1.821. All right. All right, partner. Limp Bizkit. What x values cannot exist in the domain of f of x? All right, this is friendly enough. This is fancy talk for saying what are you not allowed to plug in? I am for f of x, right? I am not allowed to plug in 0. I am not allowed to plug in the opposite of x minus 4, and I'm not allowed to plug in the opposite of x minus 5. Friendly. Use a graphing calculator. There you go. Use a graphing calculator to find the zeros of g of x. Be right back. All right, for part B here, I'm being asked to use a graphing calculator to find the zeros of g of x. So let's go to y equals and type out g of x. X is my button right there. To the fourth, make sure I go to the right to get out of the exponent, minus 6x cubed. You could do cube by doing math 3, or you could do to the third, move to the right, plus 17x. There's my x squared button, minus 54x plus 72. Let me just double check, make sure I didn't make any typos because that would derail the entire problem. I'm good. Let's graph. All right, now this is a quartic. I'm expecting it to hit my x-axis 4 times because it's a quartic. When I go to graph, it doesn't look like a quartic. So let me zoom out to make sure I'm not missing anything. So if I hit zoom out, okay, and hit enter, I am not missing anything. So what's going on here? Remember, with quartics, you can have 0 real solutions, you can have 2 real solutions, or you can have 4 real solutions. Remember, there's complex solutions. So for something like this, I could have no real solutions and have 4 complex solutions. With this, it looks like, and I'm going to zoom back to normal, so zoom 6 gets me back to normal. With this, it looks like I have 2 real solutions and 2 complex solutions. So all I have to do is find the 2 zeros. So let's do that. Let's hit second, trace, takes me to calc. My job is to find the zeros, so I can go down to 2 and hit enter, or I can just hit 2. Left bound, whenever I do this, it automatically places me at 0, so I need to go to the right a little bit until I see that little blinky cursor. There you are. Keep the left bound to the left of the 0, which it is. Hit enter, cross the x-axis, hit enter, and it's telling me in that little tiny interval right there is where my 0 exists, and it does. Let's hit enter, and I get a lovely 2. How about that? You wouldn't think, but I do get a lovely 2. So if that's 1, 2, is this going to be a lovely 4? I don't know. Let's hit second, trace to get my other 0. Go down to 2 to hit 0. Move to the right so that you're now to the left of this other 0. I just like seeing it, so hold on, there it is. So now I'm to the left of my 0, hit enter. Move to the right of my 0, hit enter. It's hard to see, but my 0 lives in between this little interval, and I do get a lovely 4. So my 2 zeros in this case are regular 2, regular 4, and I'm going to have 2 complex zeros that I really don't care about for the case of this problem. And I'm back. So the zeros ended up being very friendly. X equals 2 and 4. Remember the word that I was trying to think of a couple minutes ago and I struggled so badly? There it is. I knew it would show up. There it is, and I didn't cheat, I swear. All right, for C here, I looked at this, and I think I made a typo somewhere, so I'm going to change this. I'm going to get rid of this part to it. Okay? I'm going to just change it, because there's a typo there. I don't know what I did wrong. I did something stupid. It happens from time to time. F of x has 3 distinct zeros. Here's the thing. We don't know what A is. So A has to be different from -2 and -4. Okay? So A cannot be -2. A cannot be -4. Great. None of those, I'm ignoring this part, none of those values are a 0 of g of x. The zeros of g of x ended up being 2 and 4. So, okay, find a possible value for integer a if a is -12 and +12 in between them. I can use 5. Okay, so That would still, no, I can't use 5. I can't use 5 because of that. I can't use 4, and I know that already. I can't use 0, so let's use 7. 7 will let this work out where if I put 7 right there, if A is 7, I now have a 0 of -7, which has nothing to do with any of these, nothing to do with any of these. Nothing's going to disappear. Nothing's going to go away. Let's just stick with 7. I like it. I hated this problem that I created, although it's very similar to a problem you might see in the future. I just didn't like it. Just didn't pan out for me. So I'm going to face again. All right, now we're only using a graphing calculator, I believe, for just B. Right now, for A, we are finding an appropriate model for f of x and g of x. So we're going to look at each of these and see if it's linear, see if it's quadratic, see if it's cubic, whatever. F of x, I seem to go down by 1, go up by 1, so it's not linear, go up by 3, go up by 5. So it's not linear. Let's test to see if it's quadratic. Go up by 2, go up by 2, go up by 2. F of x is quadratic degree 2. Let's see what g of x is. Okay, g of x, I go up by 4, go up by 4, go up by 4, go up by 4 is linear. Now that I know that f of x is quadratic and g of x is linear, I could use a graphing calculator to find the equations for f of x and g of x. Be right back. Okay, well, we just found out that f of x is quadratic, and now we need to find the equation. So let's hit stat, let's hit edit, and let's type in those values. 1, enter 2. I can just use my calculator or my keyboard for this one. Don't need the calculator. Now, if you're on a keyboard, 0 is fine, but keep in mind that the negative and minus signs are different. So you're going to want to type out -1, again, the stupidest thing that Texas Instruments has ever done. 0, what else do we have? 3, 8. Okay. Let's quit out of this second mode. This one's the quadratic, so I'm going to go to stat. I'm going to go to edit. And I'm going to go to calc, and I'm going to go to quad reg, and I'm going to hit enter, 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 and then finally enter on calculate, and it gives me a lovely quadratic equation of y equals 1x squared minus 4x plus 3. So I'm going to write out y equals x squared minus 4x plus 3. Now on to the linear. If I want to clear everything out, 2 plus 712 does the job. Just don't do this on a personal calculator if you have stuff saved. Go to stat, edit. I got 1, 2, 3, 4, 5. So 1, enter 2, enter 3, enter 4, enter 5, enter. I've got 5, enter, 9, enter, 13, enter, 17, enter, 21. Don't have to worry about negatives there. Second mode. Stat, calc, linreg. So hit 4, hit enter a bunch of times, and this calculates out to y equals 4x minus 1.4. Okay? All right, so f of x ended up being, I have it written down, x squared minus 4x plus 3, and g of x ended up being just 4x. I'm looking at the wrong thing. Minus 1.4. That's why I said point. All right. Find the quotient. No calculator. Great. G of x over f of x. So we're going to need to use polynomial long division. So x squared minus 4x plus 3. That point there is just going to be a pain, a thorn in my side. Again, I create these problems, and I don't always create the best ones. But if you can figure it out, you're in great shape. 4x times what gives you regular x to the 4th? 1/4 x does that. All right, so 1/4 x times 4x gets me x squared. 1/4 x times negative 1.4. Negative 1.4 divided by 4.
It's negative 0.35.
You would never be asked to do that on a no calculator section, so I'm okay with cheating just a little bit. Flip the signs, cross u out. You become negative 3.65x plus 3. 4 times what gets me negative 3.5x. Negative 3.65 divided by 4 is?
The answer is negative 0.9125.
Negative 0.9125 x. Nope, just that. So that gets me negative 3.65x. Negative 0.9125 times negative 1.4.
It's 1.2775.
1.2775. Cross you out. Make you a minus. 3.12775. 3 minus 1.2775.
It's 1.7225.
So I would put that, my remainder, right up here. And the factor that I use to divide right here. Again, would you see something this crazy on a no calculator section? Absolutely not. But again, you know, sometimes the nice thing about these videos is if I do a bit too much and you're like, I get it. I don't like it, but I get it. Life is easy. Speaking of life is easy, this one should be a whole lot friendlier. Now, what I need to do is I need to find out what g of 8 is. Okay, well, this guy is linear. I also have a calculator. I also have these equations, and I might use that, but I don't think I really want to. In fact, I know I don't want to. G of 8, if you are 6, 7, 8, all I'm doing is adding 4 every time. So you become 25, you become 29, and g of 8 is 33. Minus f of negative 2. So 0, negative 1, negative 2. This is quadratic, so we should be able to see the pattern. Since this since it bottoms out at negative 1 and goes to 0, I know you are going to be 3. You are going to be 8, and I'm going to add 5 plus 2 more, and 5 plus 2 is 7. 7 plus 8 is 15. Okay, and that continues the pattern, all right? So, regular 15. And 33 minus regular 15 is 18. I think this whole thing uses, if I recall, this whole thing uses my graphing calculator. So let's read through the problem. During a severe rainstorm, water collects in a rain gauge. The gauge is empty at the very beginning, okay? And the amount of water follows a linear pattern up until 20 minutes. After 20 minutes, it is now quadratic. The rainstorm stops after 60 minutes. Selected values of A of t, cubic centimeters of water, in the gauge are shown below. Okay, so up until 20, it's linear. And after 20 to when it stops, which is going to be 60 minutes, it's quadratic. So I need to make a piecewise function where up to 20, I get linear. And after 20, or between 20 and 60, I get something that's quadratic. That requires a graphing calculator. I'm going to use a graphing calculator. Be right back. Well, this isn't going to be fun at all. So let's start out with the piecewise function. We are told that our data all the way up until when t is 20, we're told that it's linear. So this is what I know. I'm going to use linear regression, even though it may not be necessary. It's giving me the calculator. I'm going to show you how it's done because more money for me if I take more time to do this stuff. So I'm going to hit stat, edit. Okay, it tells me in the word problem that there's no rain at the beginning. So when time is 0, the rain amount is also 0. I also know that at 20, okay, when time is 20, my rain is 40 cubic centimeters or whatever unit that we used, right? I'm looking at the at 40. So 40, enter. Now, these are the 2 points that we know. That's it. Only those 2. But that's all we need. You only need 2 points to do lin reg. So if I quit out of this, if I go to second stat, or just regular stat, I don't know why I did that. Regular stat, hit regular stat, go right to calc and go to lin reg and hit enter a bunch of times until you get calculate. It gives you a lovely function of y equals 2x plus 0, and we will write out the equation a of t equals 2 of t, and we care about when t is less than 20, okay? Or I guess maybe in this case we could do less than or equal to 20. So that's part 1 of the piecewise function, okay? Set that aside, remember it, memorize it, because now we need to do the part that's quadratic. What I know about quadratic is at 20, it starts quadratic. So we could use that same point. So let's quit, right? Let's clear everything, because I do like to clear everything. It just makes life easier. Second plus 7, 1, 2. Go to stat, okay? Go to edit, and we're starting over. The point 20, 40 is still part of our quadratic. So we'll hit 20, and I'll get to 40 in a second. We also know that 30 is part of it. We also know that 40 is part of it. And we can move to the right and know that we can use 40, 50, 80. Okay? We know this is going to be quadratic. So let's quit by doing second mode. Let's go to stat. Let's go to calc. Let's go to quad reg, which is 5. Hit enter a bunch of times until you get to calculate and hit enter again. And it gives us an okay looking formula. Y equals 0.1 x squared minus 4x plus 8. So when I write this out on paper or choose a selection from multiple choice, I'm going to make sure I choose the one that says a of t equals 0.1 or 1/10 t squared minus 4t plus 80. Okay, and this matters between 20 and 60. Why 20 and 60? Because the rain stops at 60. So that's it. So write out your piecewise function now. All right, so knowing that my graphing calculator gave me a bunch of x's and stuff like that, I'm going to use a of t. The first part is linear. That ended up being just 2x, so 2t, where t has to be between 0 and 20. Okay, the second part was quadratic. A of t, okay, our calculator said something to the effect of 1/10 x squared, so I'll make it t squared, okay, minus 4x, so I'll make it 4t, plus 80, and that is from 20 all the way up until 60. And you know what? I can throw an or equal to there. It doesn't really matter where it begins. You're allowed to do that. That's my piecewise function. Now what I need to do is find out how long it'll take to reach 100 centimeters. Well, I don't see 100 cubic centimeters. I don't see 100 cubic centimeters anywhere on this chart, but I do know it happens after 40, which means I need to use my quadratic portion to find that out. So I'm going to pretend a of t is 100, and I'm going to I'm going to graph this guy right here and 100 in my graphing calculator. Let's see what I get. All right, so for part B here, what I'm supposed to do is find out how long it'll take to reach 100 centimeters. So if I'm looking at my piecewise function, or better yet, if I'm looking at the table, it tells me that at some point after 40 seconds, that's when my amount is going to hit 100. So what I'm going to do is I'm going to set this equal to, the equation 0.1. And instead of t squared, I'm going to hit x squared. So x squared minus 4x plus 80. And then I'm going to go down here, and I'm going to replace whatever with 100. Now, you could do this just by solving a regular old equation. You could say 100 equals 0.1 x squared minus 4x plus 80. And yeah, you're going to have to use your calculator at some point. But this is much, much, much friendlier. And you're going to want to use it this way because that's going to be a nightmare. So I have my equation right there. I have my 100 value right there. Let's hit graph. And I'm expecting to only see one of them. And it looks like in this case, I'm expecting to see neither of them. Here's why. My picture goes out to the tens, and one of my numbers is 100. See that 80 there? That 80 makes things explode way up the y-axis. So what I need to do is maybe I zoom out to find a better window to use. So I'm going to hit enter on zoom out, and I'm given nothing. So let's zoom out again. There you go. So if you want to, you can go over here and fix the window, and maybe I'll do that. Maybe I'll fix the window from negative 160 to, I'll delete, make that 70. And that's the x value, actually, not the y value. That's the x value. I'm going to make you 0. And if you're wondering, whoa, why are you doing that? I thought I saw something on the left side of the y-axis. A negative x implies a negative t, and a negative t implies time travel, and we're not doing that in precalculus. My y minimum, I'm going to start at 80, and if we hit graph, things are a little bit nicer. Now, I only care about that value right there. Again, I know that this goes over here, but I'm not going to care about the value in negative land because negative land implies time travel. Going back in time can't do that. This is not Back to the Future. So I care about my intersection. Second, trace, hit 5 for intersect. The first curve, it shows up automatically at 80. My x is 80. So I don't want 80. That's a lot. So if I hit negative, there you are. Okay. So if I hit enter on that, hit enter on this, and hit enter on that, it's going to take 44.4948, blah, 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 blah. If I round this to 3 decimal places, 44.495. Now, this is a time value, and I care about seconds in this problem. So when I solve this, I'm going to make sure I put 44.9495 seconds. That's my guy. And it's not pleasant. I believe in the video I accidentally said seconds, but it's actually 4.495 minutes, not seconds. If I said seconds, I'm sorry. I'll try to edit that if I remember to edit it out. This video is getting out of hand. Predict the amount of rain when the storm stops. When does the storm stop? At 60 minutes. So all I have to do is find out what happens at 60. Take it away. All right, so for part C here, I'm being given information that I'm supposed to plug in some number, okay? It tells me when it stops raining. I kept my original equation there. I got rid of the 100, don't need it anymore. I care about when it stops raining. When does it stop raining? When time is 60 minutes. So I'm going to make sure that I keep this up here and find out when x, I know it's t, but when x is 60. What I can do is I went to graph. I went back to graph normal. That's fine. I hit zoom 6. If you go to zoom out, I'm thinking I need to plug in 60. So why don't I do this? Why don't I go to window? And if I'm supposed to plug in x is 60, why don't I make u 70? so that I have a graph. If you're wondering, like, why do you need to do this if you're just going to plug in 60? You don't even see anything. No, and I really don't care. You can't plug in, you can't do this, which is second calc value. You can't do this unless the number you plug in is visible on the coordinate plane. So if I do second trace value and type out 60, I get a cool 200. Even though I don't see the graph, I see what I see, and what I see, I don't know why I talk like that. What I see is a nice 200. So 200 cubic centimeters, let's go with it. Oh, look at that. 200 cubic centimeters. The rainwater is so 200 cubic centimeters is transferred to a cylindrical container with a radius of 7.5 centimeters. Cylinder. So the volume of a cylinder is pi r squared h. What do I know? I know the radius is 7.5, and I know the volume is already 200. So 200 is going to equal pi 7.5 squared h. So in order to do this, I have to divide both sides by pi 7.5 squared, cross u out, divide both sides by pi 7.5 squared, and I think this requires a graphing calculator. Okay, so I did a little bit of math, and right now what I need to do is find out what 200 divided by pi 7.5 squared is. So I'm going to make sure I keep pi, which is second caret looking thing, times 7.5 squared. I'm going to keep that in parentheses because I get super paranoid when it comes to fractions on these calculators. Hit enter, and you get 1.1317 blah, 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 which simplifies, if we're using pre-calc rules, to 1.132 centimeters. That's my answer. And it did. And so the minimum height of the container is we need a container that is at least 1.132 centimeters tall. So kind of not a, you're looking at this super wide container, not tall at all. That's what you get. I mean, also that's what you get when I have to create these problems. You're just going to get what you get. Don't expect perfection. That's for Jesus. What type of model is most appropriate for the data? No calculator needed for this one. In fact, the only time I believe I'm going to use a calculator is for B and D. The table on the right shows the data of a ball thrown in the air when the ball is y feet in the air after x seconds. So what can we imply from this? All right, well, you're standing 18 feet in the air when the ball is thrown, and then it goes up, then it goes up, then it goes up, then it goes up, then it goes down, 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 down. And this doesn't even make sense because this implies negative. I wonder if that's going to show up later. Okay. What type of model is most appropriate for the demonstration to demonstrate the data? I probably already know, but let's just do it anyway. I mean, if you throw a ball up in the air and comes up and comes down, there's really only one. So what did I do? I added 14. I added 10. I added 6. I added 2. I subtract 2. I subtract 6. I subtract 10. I subtract 14. I subtract 18. It is not linear. Is it quadratic? Plus 4. Minus 4, minus 4, minus 4, minus 4, minus 4, minus 4, minus 4. It's quadratic. So let's take this information. Let's plug it all in. Oh my gosh, quadration? That's what happens when I talk and write at the same time. I'm not a wordsmith. It's quadratic. Find the equation for the data. Calculator. All right, we're almost at the end. We know we have a quadratic function, so let's go to stat, let's go to edit, and let's plug it all in. 0, 1, 2. Yes, I'm typing in all of my numbers. I'm typing them all in because I'm a math teacher and precision is key. All right, 18, 32, 42, 48, 50. Feel free to fast forward this, or while you're waiting, you click the like and subscribe button, please. What is it? 7 is 32. 8 is 18. 0. And the opposite of the Taylor Swift special is negative 22. And of course, I can't type in negative because it scares TI 84 pluses, even the color editions. All right, there we have it. I know we have a quadratic. Let's quit. Let's go to stat. Let's go to calc. And let's go to quad reg, which is 5. Okay, enter, 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 enter. Y equals ax squared plus bx plus c, where a is negative 2, b is 16, and c is 18. So y equals negative 2x squared plus 16x plus 18. Fun. Cool. So the equation that I found was, and it's y and x, so y equals negative 2x squared plus 16x plus 18. Great. What is the domain? What am I allowed to plug in? Well, I can't go back in time, so 0 is the smallest amount, and I can actually bracket that off because I can include 0. But what we found out is that after 9 seconds, I hit the ground. So 9 is the largest because once I go beyond 9, I hit negative land. Okay, so the only numbers that I can plug in are between 0 and 9, including those numbers. That's my domain, the numbers I'm allowed to plug in. Anything smaller than 0 means I did something back in the past, and anything bigger than 9 means it goes through the ground. Again, we're talking about a ball here. All right, what is the ball, or where is the ball after 5.618 seconds? That requires a graphing calculator. All right, last calculator opportunity for this one. Where is the ball at 5.61 seconds? I didn't keep my equation. In fact, I deleted everything. There is a way that if you were to go here, you can have this show up in y sub 1. I think if I go to second list, no, not worth it. 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 No, yeah, not worth it. I'll just type it out. There's a way that you could do this, but I'm not going to do it. Negative 2x squared plus 16x plus 18. If I hit the graph button, maybe I'll see a parabola. Yeah, I probably will because it's skinny. There it is. I care about where the ball is at 5.616. Unlike a previous problem, I can actually plug in 5.616 right now at this very moment. So I'll hit second, trace, value, and I'll type out 5.618. Did I keep saying 616? I think I did. 618 is what I want. That is what I want, 4.7641, which simplifies to 4.765. And that'll do it. 34.464 feet. Oh man, I hope I don't do this problem and a bunch of golfers hear me. That's 764 feet. That's what I get. Just way off today. Going off the rails. Off the rails at the very end. Find the average rate of change on 2, 4. Now, before you're like, ugh, it's not that bad. 2 is A, so I'll call you A, which means I'll call you f of A. 4 is B, so I'll call you B, and I'll call you f of B. F of B minus f of A over B minus A is going to be 50 minus 42 over 4 minus 2. 8 over 2 is 4. The average rate of change is 4 feet per second. So that's Precalculus. Watch all my other videos. Watch everything. Like and subscribe. Tell your friends, tell your family, tell your kids, tell your wife, tell your husband too, because they're telling everybody out there. Thanks for watching. Love you all. Bye.